Next presentation is entitled The Cordier Challenge, a new approach to internal mounts. B.J. Farrar is the senior Mountmaker in the Decorative Arts and Sculpture Conservation Department at the Getty Museum in Los Angeles. He specializes in the application of 3D scanning for seismic mount making, as well as being one of the early pioneers of the Mountmakers Forum, and currently he serves on the steering committee panel. Richard Hards is senior Mountmaker in Decorative Arts and Sculpture Department at the Getty Museum in Los Angeles. Richard has close to 30 years of experience in mount making and art handling. He's been instrumental in the department's use of 3D scanning technology for developing new approaches to mount making. Richard also serves on the steering committee for the IMF board.
Hi everyone, it's great to be here. Good to see everybody. 2 years goes by really fast. And thank you, Brett and Kim, for all of your hard work and your teamwork. Yeah, really great. So we're here to talk about two recent new acquisitions at the Getty Museum, at the Getty Center. Charles Cordier, a pioneering French sculptor active in the mid-19th century, was renowned for his sensitive depictions of Black and Asian sitters. His dignified representations exemplify his skills at portraiture and typically combine polychrome materials like rare colored marbles, cast bronze, silver, and enamels. In 2022, Getty acquired two of the artist's most renowned sculptures, the Sudanese Man and Woman from the French Colonies. Each object we work with presents its own challenges, but the Cordier portraits were uniquely difficult in that they were comprised of multiple parts stacked on top of one another, relying on gravity alone to keep them in place. And this just depicts the different layers. So this is a separate piece that sits just on top of his head. Then the cast bronze portraits just slip onto top of the onyx torsos. And there is a small pin that connected these two originally. We needed to disassemble the sculpture to work with each piece independently while developing an overall approach to safely unify the sculptures while on display. It was a bit of a tricky rigging job, but we eventually got it. Before the disassembly process and after, we utilized a Leo 3D scanner from Artec 3D to compile accurate dimensional information of each sculpture and its various sections. Having this digital information proved to be an invaluable tool as we progressed into designing appropriate mounts for each piece. Artec Studio, which is used to process the scans, also has a very powerful alignment feature that we use to accurately reassemble each processed sculpture section to an overall scan of each sculpture. Once this step was completed, we imported each aligned sculpture section into Rhino 3D, where we were able to start our virtual design work. Hand it over to BJ.
So the first challenge was the Sudanese Man. We started with him because he had the most challenging assembly of the pair. The big problem, not only was it comprised of 4 components, the topmost part, the turban, weighs about 26 pounds. This sits with amazing conformity and balance to a hollow cast bronze head. But the next section of the head has a very small footprint and a connection to the torso section, which is a pretty scary scenario. An internal mount seemed to be the logical solution with a vertical support from the neck pocket up from the torso up to the very top of the head. And Rhino allowed us to see inside each section to better understand how this might work and to get accurate measurements for each component. Having this virtual X-ray feature in Rhino saved us an incredible amount of time and frustration. But once we had this design, the big problem was how we were going to attach this internal support to the torso. Unfortunately, the neck area didn't have any obvious places that we would have traditionally utilized to secure our mount to the torso. We worked closely with Julie Wolfe on this project, who is a conservator in our department, and after many brainstorming decisions, we decided to focus on adhering the mount in place, something which we had not done prior to this. Ultimately, we decided to try a test with a 60% B48N mixture diluted in acetone. This was chosen for its strong bonding properties and reversibility. Since the neck cavity is a rough and uneven surface, a cast interface would also need to be incorporated, and we used a fix-it two-part epoxy putty for that. For our test, we tried to match all of the components and materials as best as possible. We cast the interface on an aluminum disc onto a rough piece of marble scrap that we had in the lab. Once this was done, we glued the interface to the marble with the B48 solution, applying an even coat to both surfaces, and allowed that to dry. An aluminum tube was cut to the length of the head and attached to the interface disc. At the end of the tube, a lead brick, which weighs about 26.25 pounds, was attached. The whole assembly was laid flat, so the brick was cantilevered from the adhered section and left to fail. As luck would have it, a whole month went by with no changes, and at that point we felt pretty confident that this method was going to work for our mount. After our testing, aluminum components were cut, and thanks to our Rhino modeling, the sizes and angles had already been determined. Multiple layers of food wrap were used as a barrier in the neck cavity before we used the fix-it epoxy putty to cast the interface to the aluminum disc. One new technique that we are trying with this process is to drill a series of small holes and channels into the interface, the resin part, after it was fully cured. The intention of this is to provide pathways deep into the adhered areas to allow channels for solvent to be put in there if the mount ever needed to be removed. Again, we utilized that 60% B48N solution and adhered the interface to the sculpture. The turban section registered quite well to the head, but we needed to come up with some form of vertical restraint. Again, Rhino gave us a clear virtual X-ray view of how the turban actually sits on the head, and it revealed that there were some large voids, as you can see up there at the kind of up on the top. There's cavities that we could utilize. Ideally, we wanted to use something simple like a microcrystalline wax as our restraint, but we needed to cast another interface to provide a more even surface for that. The voids also gave us the idea of potentially using magnets to hold the interface and turban to the top of the head and the internal mount. So we did some testing on magnets to see if that was actually possible given the size constraints that we had. And we found that if we used a very strong magnet up at the top of the internal mount, which you can see over here, and a series of smaller embedded magnets inside the cast interface, that was actually going to be achievable. And here's a view of the completed interfaces with their embedded magnets. Microcrystalline wax was used to secure the outer interface to the inside part of the turban. We also embedded a small length of monofilament into that waxed area to aid in the removal if that ever needed to be necessary. So once all those components were in place, the turban is placed, the installation is actually quite simple. The head is then placed over that internal mount section. and then the turban with the waxed interface that's in the interior is then placed on top of the head. And between the magnets and the interfaces, that alignment is already predetermined, and so installation is quite simple. Now back to Richard.
Although the woman from the French colonies lacks the marble turban present on the Sudanese man, it still had its challenges, primarily due to the restricted access within the bronze bust and somewhat precarious angle the bust sits on the torso. After separating the bronze bust from the marble torso, we realized there was a shallow cavity carved into a section of the marble. Due to the rough terrain of the carving and a slight undercut, we were able to cast a two-part locking interface into this depression. So we were able to avoid the need to adhering anything to the marble for this piece. The interface is cast onto an aluminum plate that allows for a more positive mechanical connection to the mending plate. We needed to come up with a way to make the connection between the torso and portrait mounts, and a post seemed the best solution. To locate the correct position and angle of the post, as BJ mentioned with the man, we used our RTEC Leo 3D scanner. We first scanned the marble torso with the locking interface in place. Then we scanned the bronze section separately and matched this up, aligned it with the entire sculpture that had previously been scanned. As with the Sudanese man, we were able to use the X-ray setting in Rhino to correctly locate the post and determine the length, angle, and the angle where it meets the mending plate. Once the locking interface was complete, we machined an aluminum telescoping post and bolted it from underneath the mending plate. We wanted to build in some flexibility to the system in case we needed to make minor adjustments in the final fitting. Due to the lack of access, once the portrait bust is placed onto the marble torso, we decided to use a magnetic connection for vertical restraint. We experimented with several different strengths of magnets and found the 45-pound pull force to be just right, not too difficult to remove, but a positive enough connection to feel safe. This was more in line with the Goldilocks method than anything science-based, but it works. We inset the magnet into an aluminum cap on top of the post. Our next step was to come up with an internal mount up into the neck of the bronze bust. And similar to the mount that I used on the torso, it was going to be an expanding two-part mount that would lock in place with a mending plate. Traditionally, we've used casting methods to go about this, similar to the mount that was in the torso. But the access was so bad that, and there were so many undercuts that we couldn't see, we were afraid of getting trapped if we were to cast anything in there. So eventually it dawned on us that we could try 3D print casting through Rhino, and so we used ABS as our printing filament since it has passed our Audi test, and we used Benchmark's weighted felt as a barrier. And we could spend time going into the technical details of how we go about doing this, but we can maybe answer that in the question and answer sections. But basically, it's a three-part mount that conformally fits within the neck. There's an acrylic spacer in place to keep the two upper parts locked in place while we're bolting on that lower part. And then the lower part also has a cylinder carved into it that accepts the post on the torso mount. And a steel disc is placed at bolted into the top of that, which makes the magnetic connection. The left image is a test fit of the marble torso and bronze portrait mounts. The alignment was promising. The right image is a view of the 3D printed mount from above. It's funny, we went through this entire process with restricted access, then we came in one day and to see the turban separated from the portrait. Our conservators had taken it apart for examination. We had no idea it even came apart. But at least this allowed us to see that it was working really well. Back to you, Jim.
So the last challenge to both pieces were their socle bases. And as Richard mentioned, the existing method comprised of a short steel pin that was about an inch above the base that corresponded with a small hole in the bottom of the of each torso. We X-rayed one of the socle bases just to get a better idea of what was going on. This was a very tough part of the project because despite all of the work that we did above on each piece, it really comes down to this connection to the display furniture. And the X-ray showed that pin was quite long, and it went, despite it only going up about an inch above the surface, it goes down deep about 2/3 of the way through the base. So we had multiple discussions about this and how best to approach it. And with our conservators, our curators, and ultimately we came up with the decision that we should remove the pin and continue the hole through the base. And this is a very touchy subject because everything we do is based on total reversibility, and we kind of went a little bit different on this. But we felt that ultimately this wasn't compromising the integrity of the artwork. This was the base section of it, which is separate of the carved torsos. And by doing this extension of this hole would allow us to unify the torso sections to the bases in a way that would provide ultimate safety for the pieces, into the future. So, but fortunately, from the other part of this, each torso, the receiving holes had been reinforced at some point with steel sleeves and went actually quite deeper than the pins that existed prior. So we were able to utilize that section without any alteration, and we embedded stainless steel threaded anchors with epoxy into each hole. This would allow us to do a threaded rod connection through the socle base. And as you can see in this illustration, it's kind of the assembly. The idea is that the main threaded rod goes into the threaded anchor into each torso, and then at the bottom surface of the socle bases, we employed a coupling nut, so we could unify the pieces but still have enough available thread in the coupling nut that would allow us for a removable threaded section that would allow it to be connection to the display furniture. This way, the sculptures, at least the torsos and the bases, can stay assembled, unless they need to be separated for any other reason. But it allows, for a firm connection both to the furniture and of the sculpture assemblies. So here's a short video just of the installation of the woman's portrait bust with all the mount components in place. The torso and socle base are already secured to the furniture. But ideally this is how installation should go. You've done all the hard work down in your areas, and then once you're in the galleries, the work's install simply. Thanks, everyone.
So I want to nerd out a little bit, seeing that's what we're all about here, and just say that the finish of all the internal components that no one will ever see is just amazing. So whoever the next Mountmakers that come along are going to see this and be like, wow, these guys are really good.
We have one question. How long did you have to come up with this solution?
I think the acquisitions arrived, in 2021?
Yeah.
And they just sort of sat there for a year. And probably the ideas were churning in the back of our minds for quite a while during that time. But we didn't start working on it until the summer of 2023 in earnest.
Yeah.
And then we were given an edict by the director that they needed to be up in a month. We were able to successfully push back a little bit, and we had about 2.5 months to get all of that done in the end.
But I have to say that I'm going to make a shameless plug for 3D scanning. That made it possible, especially with the woman, the connection of the internal mount to the internal vertical support, the part in the neck to the part in the torso. If we, it would have been endless trial and error until we had found like the proper alignment and connection, but the Rhino software really, that allowed us to do all of that work virtually. And the printed section that you saw we did it once, and it fit.
That saved a lot of time.
Yeah, endless time. I mean, huge.
And handling of the object.
Yes.
So much safer for the piece that we did it that way than trying to cast everything up inside of that piece.
Right.
Thank
for
you.
For the internal aspect of the hollow heads scanning, is that a wand that you insert up in there to get the internal topography, or is it some sort of like ultrasonic from the outside able to detect the cavity?
So we were using an Artec Leo 3D scanner, and it's really it's surprisingly capable at capturing internal structures. We didn't have a scope or any sort of special instruments at all. We just used the 3D Leo scanner, and it picked up what we needed to.
Yeah, I think that just the one, it's only capable of processing what it can see. So it would be wonderful to have something in the future like a scope, but at this point, it's just sort of what's visible to the scanner.
And what we really needed was just the neck area, and that was really accessible with the scanner. What wasn't accessible was up inside the head past the neck. Had we known that top piece came off, we would have been able to get. But but it gave us what we needed.
A challenge.
Yeah.
I should remember this from Gwen Spicer's book, but I'm wondering if the magnets have like a shelf life, if they retain like their 40 pounds indefinitely, or do you have to like go back and put a new magnet in at some point?
Yeah, that's a good question. I don't have a clear answer to that. I'm under the assumption that they do have a lifespan, and the embedded magnets would be more difficult to replace, obviously, than the one that's mechanically attached. But I don't have enough experience knowing what that lifespan is.
Yeah, I mean, this is really, we're really just starting to understand how we can utilize magnets in more sizable artworks, and trying to incorporate, our seismic concerns as well. So we're learning a lot.
Yeah.
So it'll be interesting to see, down the road what certain things may or may not be still functioning.
And obviously, it was much more comfortable for us that the magnet is literally in this situation all pull force. There's no shear,
Right.
and it's encapsulated in that cylinder.
Yeah.
So we felt more safe that way.
Yes, definitely. They're passive restraints. They're not the primary element.
They're taking no weight.
Thank you.
Thank you.